The rational root theorem says if p of x, a polynomial, has a rational root, then it has to be p over q, because first of all, that's what rational means. It's a fraction. But more specifically, that numerator, p, is a factor of the constant term at the end. And the denominator is going to be a factor of the leading coefficient. So we can use that if we want to factor f of x completely. I mean, first of all, we would try to factor this by parts. But if we were to cut this in half and try to factor by parts, we quickly see that it doesn't work. So what we can do instead is first come up with a list of possibilities. If there are any rational zeros to this function, the numerator of that rational zero has to be a factor of the constant of 18. So that means it has to be plus or minus 1, or 2, or 3, or 6, or 9, or 18. The denominator would have to be a factor of the leading coefficient, either 1 or 2. So what I want to do is, well, first of all, what are all of those numbers? I mean, it's quite an extensive list because we could have all of the numerators divided by 1. Or we could have all of those numerators divided by 2. Now, of course, the list isn't as bad as it looks, because when we look at 2 divided by 2, that's 1, so we wouldn't have to use that one. 6 divided by 2 is 3, that's already on the list. And 18 divided by 2 is 9, so that's on the list as well. So really, it looks like we have 9 numbers that we could possibly be, plus or minus, so a total of 18. At least it's smaller than infinitely many numbers to try, because that's what we're going to do, start trying. And we're going to try by doing synthetic division. So I'm going to take all those coefficients and start going through my list. The first one I'm going to try is 1. So we bring down the 2. 1 times 2 is 2, plus 5 is 7. 1 times 7 is 7, plus negative 9 is negative 2. And then 1 times negative 2 is negative 2, plus negative 18 makes negative 20. Since this remainder is not 0, 1 is not a 0 of f of x. The next number you should try is definitely negative 1. So do them in pairs, do the positive and then the negative. So negative 2 plus 5 is 3. Negative 3 plus 9 is negative 12. And positive 12 plus negative 18 is negative 6. So that means that 1 is not going to be 0 of f of x. So let's move on to 2. 2 times 2 is 4. 4 plus 5 is 9. 2 times 9 is 18, minus 9 is 9. 2 times 9 is 18, plus negative 18 is 0. Now that we have that 0, that means that we could rewrite f of x as x minus 2. It comes from right here. And the other one is going to be 2x squared plus 9x plus 9. And that's nice because that second one is just quadratic. We know how to factor any quadratic if it can be factored. So 2x squared gets factored into x and x. 9 will get factored into 3 and 3. That'll make plus 6x and plus 3x for the 9x that we need. If we're going to factor it completely, we can't leave this leading coefficient. So I'm going to take that 2 out. And our middle factor, when I divide out a 2 from 2x, is x. And when I divide out a 2 from 3 is 3 halves. And now we can even go one step further and identify the 3 zeros as being 2, negative 3 halves, and negative 3. Let's do another one. For g of x being x to the 4th minus x to the 3rd plus x squared minus 3x minus 6. First thing we should do is come up with the list. And our numerator is going to be plus or minus 1, 2, 3, or 6. And that all comes from our constant. Our leading coefficient is 1, so that means our only denominator would be 1. That's kind of nice. This list is quite a bit smaller than the last one. Next thing we're going to do is start trying. So we take all the coefficients, 1, -1, 1, -3, and -6. Start doing some synthetic division. Start with 1. 1 minus 1 is 0. 0 plus 1 is 1. 1 minus 3 is -2, and -2 minus 6 is -8. Since it's not positive 1, move to -1. -1 plus -1 is -2. 2 plus 1 is 3. -3 plus -3 is -6. And then 6 plus -6 is 0. Now that we have the 0, we can rewrite g of x as x plus 1 times x cubed minus 2x squared plus 3x minus 6. And that's one that we can factor by parts. If we cut this in half right here and factor out the common factor, we take out an x squared and we'll be left with x minus 2. And in the second part, we can factor out a plus 3 and we'd be left with x minus 2. Now we see that g of x is going to be x plus 1 times x minus 2, and we're left with x squared plus 3. So the 3 zeros are going to be -1 from the first one, 2 from the second one, and from the third one, that'll give us plus or minus the square root of 3i. Let's do one more big ugly one. First thing is to come up with the list. In this case, we'll get plus or minus 1, 2, or 4. And the denominators are going to be 3, so we'll have plus or minus 1/3, 2/3, or 4/3. And of course, we don't like those fractions, so we want to kind of stay away from them. But let's try them. So we'll take 3, 11, 11, 7, 8, and -4. And if we start with 1 and we bring down to 3, now we'll get 3 plus 11 is 14. 14 plus 11 is 25. 25 plus 7 is 32. 32 plus 8 is 40. And when we get down to the remainder, 40 minus 4 is 36. It's not going to be a 0. In fact, we probably could have saw that way back here. Anyway, go to -1 now. -3 plus 11 is 8. -8 plus 11 is 3. -3 plus 7 is 4. -4 plus 8 is 4. And -4 plus -4 is -8. So that one's not 0 either, which means 1 is not going to work. So let's use 2. Bring down the 3. 6 and 11 is 17. 2 times 17 is 34, plus 11 is 45, and we can see that this thing is not going to work. Every term is getting bigger and bigger, so we're not going to be able to subtract 4 and magically get 0. So let's go to -2. -6 plus 11 is 5. -10 plus 11 is 1. -2 plus 7 is 5. -10 plus 8 is -2. And 4 plus -4 is 0. Finally, we got one, and we can rewrite k of x as x plus 2 times 3x to the 4th plus 5x to the 3rd plus x squared plus 5x minus 2. And when we look at that second factor, that's not going to be easy to factor by hand. So we have to keep at it. So if we're looking at k of x being partially factored right now, and we want to continue to factor the bigger part, we should come up with a new list. The list isn't hard to come up with. When we look at the constant, we know that we're going to get plus or minus 1 or plus minus 2. The leading coefficient is still 3, so it could be plus minus 1/3 or 2/3. But what we did do is eliminate 4 as a possibility as well as 4/3. The other thing is we already tried plus or minus 1. We know that's not going to work. So now when we start trying numbers, we're going to take 3, 5, 1, 5, and -2 and start trying. And what you should try first is where you left off. And we left off with -2. because we could have the possibility that k of x is just x plus 2 to the 5th power. But let's try it. Bring down to 3. Negative 6 plus 5 is negative 1. 2 plus 1 is 3. Negative 6 plus 5 is negative 1. And 2 plus negative 2 is 0. And we see that, yeah, we did end up with a second x plus 2 as a factor. So right now we got the first x plus 2 and another x plus 2. And then we'll be left with 3x to the third minus x squared plus 3x minus 1, which can definitely be factored by parts. So let's do that. Since we have two of these x plus 2's as factors, we could just rewrite it as x plus 2 squared. And out of the front half, take out an x squared. And out of the back half, factor out a 1. Then we have it completely factored as x plus 2 squared times 3x minus 1 times x squared plus 1. Well, I guess not completely factored because we still have this this 3 as a leading coefficient of that one factor. So we'll factor out the 3. And this factor will turn into x minus 1/3. And we still got x squared plus 1. So if you had to identify your zeros, looking at the last line, we got two of them here as negative 2 and negative 2. From this one, we've got 1/3. And from the last one, that'll be the square root of negative 1, which is plus or minus I. Since we have two negative 2's, that's called a double zero, but we don't have to write it twice. So we can just write those as our zeros.